Today, I want to talk about the research that I'm doing and also the classes, the studios that we taught together about that research. So, as I said, I'm Ali Ghazvinian, and the question of my research is how might we use mycelium-based composites as the load-bearing agents for temporary structures? I want to break down this question so everyone can know what is happening here because I believe this is vague. So first start with mycelium. What is mycelium? Mycelium is the root part of the fungi. We know the fungi with the mushrooms. We eat mushrooms. We use them in many different ways, but mycelium is the root part of that. And as you can see, it has a branching structure that we call it hyphae, and it has the role to produce enzymes and break down the organic matter to simpler structures that the fungi can digest, can eat. And throughout this process starts to bind together all those organic material that is using. And if we stop this process by removing one of the major roles there, like the humidity or the fungi itself or the temperature, we can have something that we call it mycelium-based composite. And mycelium-based composites are similar to expanded polystyrene in the sense of how it builds, how it looks like, and it's really light, but with one major difference. It's bio-based and it's biodegradable. So we have something like that, but it does not harm the nature. It does not harm the world. It does not harm us. So we may need to use this material more and more. Why I'm going to see why load-bearing agents? Because I was a civil engineer. I did my bachelor's in civil engineering back in Iran, and because of that, I was interested in doing something related to the load-bearing agents, and because of that, I went this way. There are other people who are working with this material for insulation, for acoustics, for many, many more functions like packaging even. Uh, then why temporary structures? Because we have a lot of structures, a lot of pavilions, a lot of things that we make for a short while, and after that we have to throw them. And when we are throwing them, we are adding some trash to our world. So why don't we use this material that is biodegradable for those temporary structures? Also, this material is not that strong. It's a weak material mechanically, so it's better to use it for temporary structure instead of a permanent structure that we want to use for a while. To answer the part related to how might we use that, we always use this trifold cycle here that we need to go over the material, the geometry, and the technique. Sometimes we need to change the things that are related to the material. We can tweak the parameters of the cultivation of the material to have a better material. We can work on the geometry, see, okay, how different geometries can help us to use a weak material to be an structural agent, and the technique, how we want to shape that, how we want to make different forms with this material. So this trifold area is something that I'm working on for, let's say, over 7 years. And this material is something that I started to work, let's say, 3 years ago. So uh, to do that, I started to use a methodology called prototypology. I won't go and talk about that a lot, but overall, it means that instead of solving all the problems related to this material, everyone or anyone goes and helps with a chunk of that, and the collective work of the people who are working on this material or this technique or anything that is novel can make a chain. So there were prototypologies working with this material for structures, for temporary structures. I started studying them. I started to see what other people made with this material and how they did that. And with those, I found these four questions or challenges that, okay, big material, what's the organic materials? People use inorganic formworks to form that are plastic, and we are using this material because it's sustainable and it's funny if we use plastic to form that. This material is alive, it needs to breathe, and when we use that in larger scales, it cannot breathe, so it does not work for us. We need to find spatial forms for that can handle the load of the material that is big and the compaction of material. When we pull the material inside the formworks, we need to compact that, and it's a process that makes us, to use different technologies, and it's unsustainable. So I went back to one work that we did years ago in Iran with my colleague, Orman and Ismail, and the way that we formed concrete with the formwork system that we made with a 2D laser cutter system, and tried to change that in a way that it works for my steel. So I have one of the examples of that here with me, and we made those. You can see, it has different parts. I won't go to the details. And we filled that with mycelium, and we made 64 different components of mycelium, like the structure that I showed you, to make the mycocrete, the pavilion that we thought that we can make with mycelium. And it was the first prototypology that I was working on. But after 40 minutes, it collapsed. So I was thinking that, okay, there are some problems that I need to answer. They are related to the breathing of material, the contamination of the material, some protocols that we need to buy. And with those, with changing something, we could make this happen. We could make the MicroCreate 2.0 last year in, excuse me, in University of Virginia, in an exposition of the biomaterial building with my advisor, Bernard Rousseau, and our team that is a long list of names. And I want to thank them again and again. And as one of my friends always says, good research answers some questions, but the great research asks more questions. So with that, we found out these four new questions that, okay, how we want to go with the contamination, how we want to address the problem of shrinkage, how we want to work with the thickness of the material, and what if we use the biobuilding of the material? Because this material is alive, and if we put two parts of that together before drying that or before heating that to kill the mycelium, they can bind together. So with that, he started another project. It's an ongoing project. I cannot talk about that a lot, but it's called Myconit. We are using knitted textile to form the mycelium, and this is the very first prototype that we made, small one, and it happened just at the launch session with my friend who is working with the knitted textile, and we're thinking that what if we put these two together? It can help both of us. It can help you to have something that is working better because it also has some compression load, and it can also work for me because I want to form this material in thinner and in a different way. So we started this, and this is what I'm doing. But let's go and talk about the studios and how we teach this to the next generations. Because one day I was talking to my advisor, and I was thinking that, okay, this research and the results of that does not work for me if I cannot teach that to the next generations. If it's not something that the other people can do, it does not worth continuing the study. So we started the studio last year, Michael Dual in the studio with Bernard Rousseau. She was the instructor of the course. I was a TA there. We had 11 students. We talked about a system, and then we talked about them about the research that we have, and then we asked them to design some micro homes for a micro home competition with some mycelium involved. And as a side project, we asked them to help us to make that MyCoCreate 2.0 pavilion that I showed you before. Uh, the students work on different things related to mycelium. They started to think about the different ways of shaping this material. I'm showing the sheets that the students provided for us. One of our students were thinking that what if we use paper with some different chemicals that are, let's not say chemicals, organic materials that can help us not bind the paper to the mycelium, for example, some oils or some other things. And she started to use that because she was also thinking that using plastics for forming this material is the irony of the using the sustainable material. Uh, One other student was working on carving this material and shaping that, and you can see what she made. These are the carved things. Another student was thinking of additive manufacturing, printing the mycelium. She started to print some mycelium and showed us that, okay, it works for us. Uh, we had another student who was thinking of, okay, how detailed the mycelium can be in different ports. And this other one is about using the micro building or bio building, using different parts of mycelium, put them together and try to make a larger thing, and it worked for us. I talked about this already, the detail. And also we had a really great student who was thinking that what if we don't kill the mycelium and we use the fruiting bodies if we are making a house and we can use it as an edible thing. So as I said, one of our groups was shortlisted in that competition. This is the work that we've done, and this student that I said who said that okay, we can use the fruiting bodies as some sorts of food was part of the group. So the work that they've done had different panels of mycelium that the people who were using this building, this micro home, were cultivating themselves, and it can be something modular that people can bring, can take to somewhere remote and use that. And you can see this is the part that he was suggesting that we can use this the back part of the building, have some edible mushroom, and also have a regenerative factory of mycelium for us if we want to make more panels. And with that, we can make a community of these buildings. We also had students who were thinking of the same thing as we are doing right now, the mycones. They were trying to put together the textile and the mycelium. And these were the works of those students, and also forming mycelium with textile, work of another student. So these were some findings, some results from last year. And this year we started another studio with four instructors, Benoit Urso, Felicia Davis, the Faculty of Architecture, and me and Farzan Al-Fazi, my full friend, another PhD candidate in our department. And this year we have 12 students. One of the things that happened this year was four of our students from last year took the studio again, and it was a really great fortune for me because I was thinking that okay, this is something interesting that they are coming back. So yes, and we are thinking of doing the micronic project as part of the IASS UG21 competition for next year. In June in Melbourne, they are trying to make something like for that competition. And the reason that I'm talking, too fast is that because today, around an hour from now, we have the review of this studio. So you are all welcome to join us. It will be in the third floor of Stuckman building in the mezzanine. You are welcome. You can come and see what our students have done. I was running all the morning to make the models and bring the models that they made to the class because we work in another facility in the university. So it was all, and I will share more about my comments in the future, maybe in my defense, because my time is limited here. I think I passed my time, but I want one more minute, and I want you all to follow this. Uh, you know, I'm from Iran. Something really important is happening in Iran, and it's an uprising, it's a revolution for people of Iran. It started with the death of a woman, a 22-year woman, Mahsa Amini. If you follow the hashtag Mahsa Amini, you can see the news about that, or you can see the thing that people are chanting, woman life freedom. And this is not something about Iran, something about the world, because we have a song that is kind of the manifesto of this revolution. It's called Baroye, which means for the sake of. And four lines of that is talking about something that is related to the sustainability, to the environment. You can see that. It says for the polluted air, for the dying trees of Galias Strait in Tehran, for the pirus, the endangered Iranian cheetah, and for the dogs that are prohibited in Iran. So this revolution is about everything, and also the environment. As sustainability fellows, we need to follow this. We need to spread the word, and we need to be the voice of people in Europe. Thank you very much, and I'm open to every questions. And again, you are all welcome to join us for the review today.